Hi everyone, in this video I'm going to be talking about what is a limiting reagent. Okay, so let's begin. If we think logically, the word limiting actually tells us something which is going to limit my reaction. Okay, limit my reaction to reach its full potential. That's what a limiting reagent should logically do. So correct, logic is totally fine. A limiting reagent is going to do nothing, but because of the less quantity in which it is present, the reagent which is present in the less quantity, because of that it is going to limit the product formation, and that is what a limiting reagent is. Okay, so if I try to give you a small example, we all know how to make tea. Okay, if you don't, you should learn that. So tea is basically made up of four ingredients. Okay, that is milk, there is sugar. Okay, if you do not drink sugarless tea, then there is water, and there is tea, which is tea leaves finally. Okay, now if I have all these ingredients with me, I can make tea very easily. Okay, but let's say I have milk with me in a good quantity, sugar also in a good quantity, water also in a good quantity, but tea leaves I only have 2 spoons. Okay, only 2 spoons of tea leaves are left with me. So in this case, no matter how much milk, sugar and water I have, I will only be able to make tea that is enough, that can be made out of these 2 spoons present. Okay, so all these three ingredients which are present in excess with me, these are called excess reagents, and they're not even required. Okay, because no matter they are present or not, the only amount of tea which I can make is because of these 2 spoons. Okay, so in this case, tea leaves is actually a limiting reagent here, because this small quantity of tea leaves actually limits my tea formation, and I cannot make the tea till my full extent, which means a large quantity of tea. So now let's start with the chemistry of it. This is a small example which I gave you to just understand the topic, and now let's deep dive into the chemistry part. So in chemistry, we have reactions in which we have a single reactant. Okay, so those reactants are called by unimolecular reactants. So we have A changes to B. This kind of reaction is called a unimolecular reaction. In these reactions, I do not require a limiting reagent, because of course there's only one reactant. Okay, so this reactant, however much I have this reactant, I will be able to make B out of however much amount of A I have, and that is going to be enough. But in cases where I have multiple reactants with me, okay, in cases like this, I will require the concept of limiting reagent, because now I have to think about which reaction is present in a less quantity, and then I will be moving on to the calculation of product by using that reactant which is present in less quantity. Okay, so now these kind of reactions are important to me for limiting reagent. Now the first thing which I have to think about and I have to always keep in mind is always used a balanced chemical equation. This is the most important thing, and I don't know how much I should stress on this, because if you are not using a balanced chemical equation, your stoichiometry is not correct, and the answer of course is not going to be correct. Okay, so all your efforts are going to be in vain. So first and the foremost thing is use a balanced chemical equation. So let's do that. Now let's say I have an equation with me, okay, and I have to go and find a limiting reagent out of it. Okay, and hence find the product. So let's say my reaction is H2 plus O2 gives H2. The first thing that I notice is that the reaction is not balanced, so I have to do that. Okay, so this 2H2 plus O2 gives 2H2. Now this equation looks balanced enough. Now how do I read this reaction? I can read this reaction as 2 moles of H2, okay, combined with 2 moles, one single mole of O2 to form 2 moles of water, right? I can read this equation in form of moles, or I can read this equation also in form of molecules. 2 molecules of H2 combined with 1 molecule of O2 to form 2 molecules of H2. Is that correct? Okay, so when we do this, this number 2 here and number 1 here and this number 2 here, okay, this is nothing but the stoichiometry of the reaction. Okay, so I can change this stoichiometry. This stoichiometry comes only after balancing, and correct balancing, if I may stress on that, because if you are not doing correct balancing, your stoichiometry of course is not correct, and your answer is not going to be correct, right? So stoichiometry is this word written here, okay, in front of your molecule. If there's nothing, it's 1, right? And this is the most important aspect of limiting reagent. Okay, now how do we calculate the limiting reagent? Limiting reagent की जो formula है, that is nothing, it's very simply number of moles divided by your stoichiometry. Okay, This is the formula for limiting reagent. Okay, so I have given you all the background of the story, and I think we should start a numerical, and then it is going to be quite clear. This is a numerical which is present in your NCERT. This is an example, in your NCERT. 50 kg of N2 and 10 kg of H2 are mixed to form NH3, which is ammonia. Calculate the amount of NH3 formed and identify the limiting reagent. It's not written here, so I've written. So the first and foremost thing is they have not given me the equation, so I should write the equation. There's N2 and there's H2, and there's a formation of ammonia, which is NH3. Okay. The first and the foremost thing which I notice is the reaction is not balanced. Okay, let's do that. So there's 2 NH3 here. So there's 2 and there's 6. So there's 3. So I hope this equation is balanced enough. Now, since this equation is balanced enough, can I see my stoichiometric numbers? N is 1, H2 is 3, and ammonia is 2. Okay, these are my stoichiometric numbers. Now I am also given their amount. So N2 is present 50 kg. Okay, H2 is 10 kg, and I have to find out the amount of ammonia which is formed. Of course, since there are two reactants, multiple reactants are there, so I have to first think about what is my limiting reagent, and according to that my product is going to be formed, right? Okay, so how do we do that? We have to find the limiting reagent. Limiting reagent is number of moles, okay, divided by stoichiometry. So stoichiometry is quite clear to me. Here is 1, this is 3, this is 2. Okay, stoichiometry is clear to me. I have to find out the number of moles. So let's do that. 50 kg is my mass here. So what is the number of moles? It is given mass upon molar mass. So since both should be in grams, I'll convert this 50 kg into grams. Okay, and this is N2, this is 28, right? And this is the number of moles of N2. Number of moles of H2 is 10 into, again converting into grams, okay, upon 2, because 2 is the molar mass of H2. So if I calculate this, this comes out to be somewhere equal to 1785, I guess, okay, 0.7, and this comes out to be equal to 5000. Okay, so now this is my number of moles. Don't think of this number as my limiting reagent. Limiting reagent is number of moles divided by stoichiometry. So now, since I have the number of moles, I'll divide them by the stoichiometry. So this divided by, in this case, stoichiometry N2 is 1. This is going to be 1, and this is divided by 3. The stoichiometry here is 3. Okay, so this comes out to be approximately equal to 1666.6. So now I have to compare these two numbers, this number and 1785 divided by 1 is 1, right? So this number. Out of these two, I can see this is my smaller number, and now I know that my H2 or dihydrogen is my limiting reagent. So the dihydrogen is going to identify or is going to determine the amount of product which is formed. So now I guess the calculation is simply nothing but your unitary method. So let's do that. Okay, so now 3 moles of H2 gives rise to 2 moles of NH3. Is that clear? I can see that from the balanced chemical equation. Now 1 mole is going to give rise to 2 divided by 3. And how many moles do I have? I have 5000 moles, right? So 5000 moles of H2 is going to give rise to 2 by 3 into 5000 moles of ammonia, which is NH3. Clear? But in the question, they have asked me in grams. So I have to provide the answer in grams. What I'm providing right now is a number of moles. So nothing, it's not very difficult. Number of moles, say we can easily calculate the amount. So I'll just do nothing and just multiply this answer with the molar mass of ammonia, which is 2 by 3 into 5000. Whatever the answer comes out to be is going to be in number of moles, is going to be in moles. I'll multiply by 17, which is the molar mass of ammonia, and I will get my answer, okay, in grams. So I hope we are clear with what is limiting reagent and how do we calculate limiting reagent. The most important thing, I think I'm stressing on it again, is always balance your chemical equation, only then start with the question. And if you have any further doubts, you can ask me, and stay tuned for more.